Hello everyone. I hope you all are doing well. This side Priya Bhatia. And now in this video, we will continue our discussion. And the next phase of our pipeline is model training, as we already have discussed. So now what we will do is we will try to create a pipeline to train our model with a logistic regression algorithm. One minute change I have done here in the outlier detection part is that in the last video, if I have shown you, I have directly taken the data new, but we need to make sure that the number of samples in the input features should be equivalent to the number of samples in the output features, right? There should be a match. Then only you will start the model training. So what I have done is I have tried to store that value of X insulin, which is less than the 95 percentile in the mask. And then I have tried to use that to fetch the data points available in the input features, and same is the y outlier detection, right? So this is something which is a necessary step. I have done for the X part in the last video. We have to do the same thing for the Y part, so that we will be having equal number of data points in both input features and the output sample. So now you can see we will be having 721 features in the input features part, and 71 is the output value. Sometimes you might face an error while doing the same task due to the indexing issue. So what you can do is you can just reset the index to make sure that both of them indexing will start from zero. That's the only thing which you have to do. Okay, perfect. So now, somehow, if you remember in the last session, we already have deal with the outliers, and now it's the time to do the model training. And to do the model training, the very first step is to split our data into training and testing path. So in total, we will be having 721 data points, and now it's the right time, I believe, that we should split our data into training and testing. To do that, we will use this sklearn.model selection part, in which we have a function name train underscore test underscore split. If you want, you can refer this documentation as well. It's openly available on the Chrome. Just search sklearn test train split. You will be able to get this documentation. So here you can see these are the parameters that we have, which is I can copy it here. So this is the first step, where what we are trying to do is we're trying to do the splitting of data into training and testing. Okay? So why is the split is required? Let's try to understand this in the very first part. So here you can see, right? Here you can see that, let's say we will be having 1000 data points. So usually what happened is we are trying to split our data maybe in the ratio, let's say 80 to 20. So what we are saying, almost 800 points we are trying to deliver into the training part. We will train our model. Maybe as of now we are working on logistic regression algorithm. Maybe in future you will be working on some different model. So it doesn't matter what kind of model you are using. It's just that you are using those 800 points to train your model. And by the way, this number is not fixed, but it's just said that training points should be quite higher as comparable to testing points. So you can take 80-20 ratio, you can take 70-30 ratio. It really depends on you. And then let's say 200 points goes to the testing part per se. You know that we will be having actual values available with us, 200 points corresponding actual values, that whether the patient is diabetic or not. And when we train our model on our 800 data points that we have, we will be having the model predictions as well on this 200 points, right? So what we will do is we will try to compare the results that we will be able to get from the actual result set and the predicted result set. Let's say in the actual you're having a value of 1, means the patient is diabetic, but prediction is saying it is 0. So again, it's a error, right? But let's say your prediction says 0 and it actually is also 0. It means it's a good value, right? So what we want in general, we want minimum error rate, we want maximum accuracy. This is what we want to get, right, at the end of the day. Usually what happened, you will see that we can divide our data into 3 components as well. Validation set is a third component, but as of now I'm not going in that direction, because that is basically used for the hyperparameter tuning, which I'm not covering up intentionally here. Maybe in the upcoming advanced level projects we will cover up that as well. But for now, you can consider in a simplest term, if you are just starting your journey out. So as of now, you can consider that training is to train the model, testing is to do the prediction and compare with the actual data points that we have. That's the simple scenario which I'm giving you. In future, once I will talk about the hyperparameter tuning, what is that all about? How can we do that? What's the mathematical intuition behind that? Maybe in that scenario, we will discuss the validation set as well, and we will discuss, what's the importance of that. But for now, just skip that part, okay? So let's get started with the splitting part. So here you can see as we are using that train test set. Now to use that, you can see there is an error coming up. So what we can do is we can import that thing first. From sklearn dot model underscore selection, what you can do is you can import train underscore test underscore split function, right? After that, you can use this function. Now your x is not this, bulky data new is the parameter that you have, and your y is nothing but I think y underscore outlier underscore detection. So let's use this as a y parameter that we have. And as of now, we are using this test size as 33%. It means that I am saying almost 33% of data contains my testing set, and remaining data points that we have correspond to the training set. Here we have random state, right? This random state indicates that, let's say you are working on your code, and let's say I'm working on my code. And if we both want that we have a same training set and testing set, so we will try to give similar number there. Otherwise, what will happen at every time when you run the model, your results might change because you will be having a different set of training and testing set. It will be random. So if you just fix with this number of random state, it will be always similar. That's why you can use this number as it is, so that we will be having similar kind of results. That's the only idea behind this random underscore state parameter in this particular code. Let's try to run this code now, and boom, we will be able to have now training and testing set with us. What is the next step? Now, here you can see that what is the shape of this X train. If you just want to see this, let's see. So it means we will be having 483 points, which belongs to training set. And if I'll just show you the shape of the test set that we have, you will be able to see almost 238 points are there, which belongs to test set. You can see 33% data points are available in the testing set, which is what we have delivered in the parameter as well. Now, if let's say I will show you the y underscore train dot value underscore counts, right? This is where interesting thing will come up. You can see that in this training set, there is a biasness. What is a biasness? You will observe that 0 records correspond to how many number of records? 318. And 1 belongs to 165. So you can see 0 label data is almost double than the 1 label data. And this is something which we call as imbalanced. Data imbalancing, you can say. Data imbalancing says that you will be having one class almost double, triple, 4 times data points as comparable to another class. And you will observe that in healthcare based data, this is a very common issue, because you only observe now that, let's say I am saying the number of people who are having cancer, definitely that number should be small as comparable to the number of people who don't have. So always you will observe key data points in healthcare domain, the people who don't have a disease is much higher as comparable to the people who are actually suffering from that disease. Be it any disease, diabetes, sugar, pneumonia, when COVID came, right? At the time of cancer, brain tumor, anything you can consider in the healthcare, you will always observe that this kind of problem is there. That is where we can resolve this issue with the help of multiple techniques. Very famous are oversampling and undersampling. In oversampling, what we usually do is we will try to increase the number of samples. Let's say we have one labeled as 165. So we will try to take the random samples multiple times to make it number as 318. In undersampling, we try to reduce the majority class, that is 318 to 165. So it's vice versa. We have a smart technique as well, which is also similar to oversampling only, where we will try to generate a synthetic data. So any of the technique you can apply in order to create the samples, but anyhow you have to handle this situation. So what I'm saying is there are multiple techniques to handle this situation. First technique is oversampling. Second technique is undersampling. And the third technique, which is a part of, you can say, oversampling only, is the smart technique, where we are trying to generate a synthetic data. So you will observe one thing here, that be it any technique, right? The task is same. We are trying to balance the 0 labeled class and the 1 labeled class. In oversampling, what we are doing is we will try to take the minority class that we have and increase that number, increase that number to the majority class. That is the task of oversampling. In undersampling, we will take the majority class, and we will try to decrease that number to the minority class, vice versa, I would say. And in smooth technique, what we will do is we will try to somehow generate the synthetic data, and again, we'll try to increase the number of number of samples to the majority class. So this is how the things will be done. There is a, you can again say, documentation of IMB learn documentation. IMB indicates imbalanced class, and you will be able to see the implementation of each and every technique that I'm talking about here. You can just refer that user guide and you will be able to see the code there. So as of now, what I'm doing is I'm applying this mode technique, but anyhow, you can apply any kind of technique on top of this to get it that same number. Okay. So what I'm doing here is I'm using IMB learn. As I told you, it's an oversampling part only. I'm importing that smooth function. So what we are doing is we are trying to get a resample data on the basis of this X train and Y train. So after that, if you will be able to see Y underscore train underscore resample value underscore count, you will be able to see now we will be having a similar count, right? So this is how basically we have handled our imbalanced task pretty well. So now we will be having almost equal number of values available as 0 and 1. Okay? This is how basically data imbalancing will be done. Issue will be fixed out right here. The same thing you can do, instead of importing that smooth, you can import undersampling, oversampling. It's your wish and you can do that, right? Random oversampler is the class for oversampling, and random undersampler is the class of undersampling. As I told you, this is the task which you have to perform at your own. It's very, very simple, right? So with this, let's end today's video. In upcoming video, now we actually start doing the training process of logistic regression algorithm. In this video, we just have seen that there is an issue of data imbalancing and how basically we can fix that. One of the techniques that we have. In the upcoming video, we will do the implementation of our algorithm now. So I hope that until this part, everything is clear to everyone. If you still have any issue, please do reach out to me. I will for sure try to resolve it as soon as possible. With this, happy learning to all. Bye-bye everyone. I'll see you all very soon in the upcoming video.